Hey, this is OXDF. Today we're looking at Advent of Code 2022, Day 23, Unstable Diffusion. I'm actually traveling right now, so I don't have my normal setup, so apologies if the sound isn't as great, and I don't have my camera, so we're going to go back to the old days of cameraless. All right, let's take a look at the problem. This was a much easier day given after yesterday. We're going to get a grid that looks kind of like this, where the pound signs or hash marks represent elves, and the elves are going to move. So they say north is up, south is down, west is east, west is left, east is right. So basically, each round, each elf is going to first pick where it wants to move. So it'll start by looking north, northeast, and northwest, and if all three of these are open, it plans to move north. Then it'll look, if that's not, if one of those is full, it'll say, oh, it's too crowded, I'm looking south. And if all three, south, southeast, and southwest are open, it'll plan to move south, and then it's the same thing with west and same thing with east. The one trick here is each round, what direction comes first rotates. So the first round will go north, south, west, east. The second round, south, west, east, north, then west, east, north, south, then east, north, south, west, and back to starting with north, etc. So the second part is once they've all decided where they're going to move, then they actually start to move simultaneously. And for that, each elf is going to look at where it was planning to move. And if no other elf was planning to move there, it'll move, otherwise it'll stay the same. And I think that is basically it. It gives a couple examples to work through, but the rules are pretty same. And so we're supposed to look for part one. We're supposed to solve, okay, after 10 rounds, draw, get the smallest x's and y's, and draw a box around it, and then count how many spaces don't have elves. So the area of that rectangle minus the number of elves. I already solved this. I'm trying to do this kind of live on this. My current setup is going to be too challenging. So we have an answer here. We'll go ahead and look at part two while we're here, though. So now they want you to keep moving until the elves all stop. So eventually they're going to get far enough apart that they're just going to stop, that no one's going to have any moves. I think I neglected to say at the beginning, the first thing an elf does is if all 8 spaces around it are empty, it just stays put. So eventually the elves will all tend towards doing nothing. We're supposed to do that point, and we're supposed to give us the number of the round with the elf has no. So we have both answers here. And we can kind of solve these at the same time. This was not a challenge where I felt like we had to do a big twist into part 1 and 2. So we'll start by, there's a couple things we gotta keep track of. I'm gonna ignore this score function for now. We'll come back to that. Smaller. So we're gonna read all the lines in. I've defined here the spaces. Moves is probably the wrong name for this, but it's the spaces that you need to check to move in a direction. So if you're going to move north, you need to look 1 row up, 1 column left, 1 row up, no columns left, like straight above you, and then 1 column up, 1 column right. So northwest, north, and northeast. Similarly, if you're going to move south, it's going to be southwest, south, and southeast, etc. So that's just those points so I can use them later to make it a little less. I'm going to define a grid, like a map or whatever. It's going to be a set. So it'll be the points where the elves are. I probably should have called it elves, honestly. It's good to update that. But and then I'll keep track of the number of elves. So for each, I'll loop over the lines, taking the rows, and for each row I'll take the characters. And if the character is a pound sign for an elf, I will add that to our grid. I probably again should have called it elves, and I will increase our number of elves. Probably don't need that count, actually. I probably just get LAN of grid in hindsight, but we're improving as we go here. Now we're going to start our rounds. When I was doing just part 1, I did this in this part right here, lines 36 and 37 in a for loop, like 4 round in range 10. But for round 2, I have a kind of unknown number, so I switched it to a while loop. We're going to start by, at the beginning of each round, we'll define a default dict that is a list. That means it's kind of like a dictionary, and if the item doesn't exist in the dictionary, then it kind of creates one with an empty list as the contents. And that is where I'm going to store the next moves. I'll show how to do that in a minute. Then we'll loop over each elf. Really should have named grid elf. And we'll get its coordinates. And the first thing we're going to do is we're going to check and see if there's no neighbor. So this is a little bit convoluted, but basically for change in column from -1, 0, and 1, and then for change in range from the same range, we're going to say 1 if dr, r plus dr, c plus dc is in grid. So we're going to count if there's an elf in any of the spaces. we should only get 1 because there's always going to be, for 0, 0, there's going to be 1. And so when we sum all this up, if there's only 1, we're just going to continue. The add elf is done, it's not going to move. If we get anything else, we should never get 0 because the elf is there. But if we get anything higher than 0, we should keep going. Now we're going to check for the next move. And so there's four checks to make, right? North, south, east, west, or north, south, west, east is the first round, and then that round changes. And so what I'm going to do is I'm going to have this moves, which we looked up here as the north, south, west, east. I'm going to do M, so which round, checking 1, 0, 1, 2, and 3, plus the current round we're in, mod 4. And that's going to allow me to rotate per round. So that means the first round will start with north, but the second round will start with a 1 and do 1, 2, 3, and then 0. So that'll get our potential moves. We'll do a very similar list comprehension here to basically say we'll put a 1 for each of these if it's in grid, and if it's equal to 0, which means all 3 of those spots are empty, then we're going to add to our next moves. And this is the tricky part, I think, or this is or it's clever, I think. We're going to add in the place we'd be moving to as the key, and then the place we're moving from as the value. We're going to append that as. So we keep track of both the from and the to. And then we break because we're done. Once we find a move, we need to keep finding it. Once we're done with recording the potential moves for all the elves, now we come back here and execute them. So for move to, comma, move from, in next move for items. And so items is going to return key, comma, value for each item. So this will be the key, move to, and then move from will be a list of items moving into that thing. If the length of move from is 1, so if only one elf wants to move into that spot, we're going to do the move. If anything else happens, we're just going to skip the move and ignore them. So in this case, doing the move means adding a grid, adding an elf to the place move to, and removing the one item and move from the grid or list of elves. Now again, before when I originally did part 1, that's just sort of so that the for loop of 10 end, and I calculated. Instead, we're going to now increment our round. If round equals 10, so we just completed our 10th round, 0 through 9, now we're 10. We're going to print our score function on that and print part 1. Otherwise, we're going to check and say, like, oh, is the length of number moves 0? So if there were no moves queued up, that means all the elves were happy where they were. Then we're going to break out of our loop and we'll print part 2, which is just to get the current round number. The only thing I didn't really show here is the score. And the score here is pretty simple. We're just going to get the minimum row, the maximum row, the minimum column, the maximum column. Then we're going to multiply those together to get the area of a box and subtract off non-elves. And again, I think we can make this better. So I can run this. I can show you. This runs pretty quickly. It helps if I am in the right folder. Python J23 input here. Runs very quickly and gives us the answers. I say very quickly, it should be pretty quickly. Maybe part 2 is a little bit, a few seconds. The answers we're looking for are 38, 77, and 82. Oh, nope, it's longer than I remember. So 982. We could do some things here. I talked about some potential improvements by, but the improvements are not going to speed it up. We could. I don't need num-elves. I could just do len. I could rename. I'll probably do that for the code I push up. But yeah, that's how I solved it. Pretty easy day, given it's day 23, and maybe they're being nice to us after yesterday was really painful. But yeah, tell me how you shared it in the comments. Thanks for sticking around with me to the end, and I'll talk to you tomorrow. Bye.